Hi and welcome back to this introduction to R programming part number 2, and this is gonna be about elements, which kind of elements you are gonna find in R, and it's like the ground to build the knowledge in R, and I think it's one of the most important lessons that we need to know, because R is a language that if you grasp the basics of it can be extremely powerful, and it's not so difficult. But if you do not know well the basics, it can get really difficult or prone to errors or to go very slow. So I would say that this is one of the most important lessons in R, the basics. And so let's go to it, and let's begin by classes in R. So this is the kind of data that you are gonna find, which kind of data, like numbers or words or dates, etc. And let's begin with atomic data. So atomic means that there is only one element, like one number or one character or one date, for example. Okay, so the first kind of atomic data that we find in R are the integers. So I will do like real-time coding, and as we saw in the previous lesson, we have here up I have the source panel, and down here in this place I have the console. Okay, so let's say that I have a variable which is called x, and I want to assign the number 22, for example. So instead of doing x equal 22, in R there is another symbol which is almost equivalent, but it's not the same. It's also assigning a value to a variable, and it's this one. So first we type this less than, and after this one, and we can put like this. Okay, so this is gonna say that 22 is assigned to variable x, so it's like an arrow that goes from the number to the variable. If I want to specify it's an integer, I will do, after the number, I will add this capital L to it, and that's saying that it really has to be an integer and is not a real number, it's only an integer. So if I want to say to R that okay, so go on and assign this value, I will push Ctrl Enter, and then you see in the console down here you have that. So let me change, before we continue, the size of everything here, and I will go in RStudio Preferences and appearance, and I will change the font size to 12. Like this in the video is gonna be easier for you to see it. So let's perhaps change it to 13 if we can. Yes, like this is gonna be really big and you will see it. Okay, so now it's better. So you see we are here, x assigned to the value 22. Control Enter, and here down in the console we can see the result of the assignment. There was no anything printed as which is the value. If we want to do that, we can only put this one like x, Control Enter, and we see it here down, the result of it. So that means that there is one element in x and the value is 22. Let's check which is the class of x, if it's an integer, if it's a character. So if I say class parentheses of x, I do the same, Control Enter, and it says to me here in the console, it says to me that it's an integer. Okay, so now what can we do with integers? So we can add integers together, like x plus 12, Control Enter, 34. Yeah, we can multiply, we can divide, can also create a new one, x assigned to number to this one, and then now I can control enter to put it in memory, and then I can make operation like this one, x plus y 145, etc. Okay, x times y. I can also apply functions to a series of numbers. Like now I have two variables x and y, so I can calculate the maximum of them. So this is the function max, parentheses, and now I want to put together these two numbers, variables x and y. So this is using this like operation, which is called concatenate. So I say concatenate what? Concatenate x and y together, and you calculate the maximum of these two ones. So control enter, and it's 123. Okay, so that's a way to make functions. There is also another function which is called isInteger of x, and I can see here down that it is true. But if I put this one isInteger of 12.3, it's gonna be false. Okay. Okay, so these are the integers. We can assign, we can make arithmetics, we can make functions, and we will see more details about it. Okay, we can also apply these kind of functions. So it's x greater than y, false. Okay, and this is what we have seen previously. And this is, we can erase that. Okay, so now we can move to double numbers, which are called in R numeric. It means that it can be these kind of numbers with decimal values, not only whole numbers. So if I assign x to the number 12 and I don't specify that it's an integer with this capital L, I will see that x, the value of x now is gonna be, the class of x is gonna be numeric by default. Okay, so this is something new, as you see here. This I will do it now like this. So I can assign this value to 12, and with control enter, if I want to put several commands in the same line, I can separate it with this semicolon here. So now I'm saying 12 goes to x, and now show me x, like I put it like alone like this. So then now I make control, and before it's gonna assign the value, and after it's gonna show it to me in the console, as you can see here down here. Okay, so now let's look for the class of x. Class of x, control enter, is numeric. It's not an integer, it's numeric now. Okay, same with these kind of values. I also can do this scientific notation here. As you can see here, it's 12 times exponential of 10 2, so it means 12 times 100, because it's 10 with 2 zeros. If I would do it like this, 12 6, that would be 12 millions, because it's 10 with 6 zeros, no? So let's assign that, and let's show x. You see, so it's 1.2 E7, which is 12 millions. Another way to print results when they are more complicated, or when they are in functions, we can say this command, print x, and it's gonna show it also in the console, but it's gonna force to print, and sometimes it's useful. So we can transform integer numbers to numeric if we do like this, as numeric 123L. We can also apply functions to these numbers, like square of doubles, and same kind of arithmetics that we have with integers. Okay, so let's move to the next one, which is character. So character, it's a string, so it's letters together making a word or making a sentence or making a text. And so some variables can have these elements which are character. Okay, so let's, if I say that x is assigned to hello, so I'm gonna have this, and the class of x is gonna be character. Okay, I can also make that y is high, and now to put them together, there is one command which is called paste. Paste is gonna paste together these two ones. Let me assign now high without a space before, like this, and now you will see that when I paste the two one together, you will see here down in the console that the result is hello high. There is a space between the two variables added by default. I can change that if I make paste x, y, and the value of the parameter sep, which is separation. I'm gonna say, for example, that is this one, percentage. So then if I apply that with Control Enter, as always, I will have the result here down in the console, which is hello high separated by that. Okay, other operations I can do in character, and we are gonna see a lot of them because it's very useful to know how to change or look for values in strings and in character fields. So one of the most used functions is a gsub, that is replacing something by other thing in the variable. So now x is hello. I am saying with this command, I am saying that you are gonna replace x, looking for the for this string and replacing by this one. So let's apply that, and you see here down the result of it is hello with all these chains. We can make a very complicated operation with that. Another very common one, it's this one, which is a logical grep. Grep means that look for something, search for some strings in a string. So let's see if it's true that we have the character e in x. Okay, so then we will have a true or a false if it contains that. So in this case, this is true. But if, for example, we say that if can you find this in x, so now it is false. Okay, so this is two functions that we're gonna use a lot, and also paste is gonna be used. But characters are also powerful elements in R. Let's move to the next one, which is logical. So logical, it's an element, a variable, which can have only two values. It's false or it is true. So let's say that now x is true. Sorry, x is true. So if I want to show x, you will see here down true. If I say like I am saying here down, let me erase that, and that y is false, I can make some operations over them, like r, or this is the command to say or y. So x or y will say that if one of the two is true, it's gonna be true. If the two are false, it's gonna be false, etc. So x or y, the result is true. And this is a little bit more complicated one, which means that x and y, or y. So this is gonna be false because x and y, it's false because there is one of them which is false, and or y is gonna be false because the two of them are false. Okay, so this is also very useful, for example, in this kind of commands. If x, so if x is true, then y equal, for example, to true. Okay, so this is a command that we can say, and now we check why, and now it has become true. So we can apply these kind of conditions, which are very extremely useful when we make some programming. Okay, let's move to the next one, which is a date. So dates in R, as in SAS and in other programming languages, are numbers, but they have specific formats and specific functions over them. In R, dates are numeric values, and they are, in reality, they are integers, but they show as integers, but they are numeric because it can be also, dates can have also non-integer values. And the default string format to display a date, it's like that. So I didn't say that, but to make a character, we quote them. So let's say that D is 1989. This is the year. First comes the year, after comes the month, and after comes the day. This is the default value for the dates in R. Okay, so now this is like a character, because I didn't say it's date, but I can say now that this one is as a date. So put this string as if it's a date. Okay, and now show it to me. So I do that, and I see the result here that is displayed as a string. Also D is displayed as a string, but they are different because D it's only a string, and DD it's a date. You will see that because now if I say as numeric, so show me or transform the value of DD to a number. So this is the number 7242. And what is that number? So that number is the number of days that are from 1970, the 1st of January, to the date that we are assigning. So when we also can make as date this number 242. So I am saying transform this number to a date, but I have to specify the origin, which is the day number 1. So by default in R, the dates are taken from this date here. So then I can do that, and I get the same result here. You will see down, which is this date. Okay, so I can transform numbers to dates, and I can transform characters to dates. So this is another way to transform a specific format of a date to a date, because I'm specifying here. So let's do it in real time. So why I say I want to be as a date, what do I have? I have a string which is 12 of the 10th of the year 99, but now it's not the default format, so I have to specify which is the format of it. So I quote, the format is gonna be, first I have a day, so it's this percentage D, that means format of day with 2 numbers. This is separated by this slash, and now percentage M slash, because M says it's a month, and a slash now a year, small e, because it's only 2 numbers. If it was 4 numbers, I would put a capital Y. So now I put this, and it's gonna understand now what is that, and I can check it, date 1999, etc. Okay, because internally a date it's a number, I can add things. I will be adding days. So y plus 3, it's, instead of being the 12th, is the 15th. I can also apply functions, more complex functions, over this one. For example, weekdays of date y, it's a Tuesday. So that means that that day, specifically if I want to find which is the weekday, I will find it Tuesday. Okay, there is a lot of functions and there is very useful packages to compute things over dates, like finding the year, finding the number of days since one day of the week of 1 year, etc. And we are gonna use that a lot because in screening and in epidemiology, and there is lots of dates with diagnoses and etc. Okay, so let's move to the next one, factors. Factors are very, very important in R. They are one of the key elements of R, and they are also kind of tricky, and it's very, very important that we understand how they work. And so I will spend a little bit of time here because it's gonna be one of the grounding basics of the powerful R. Okay, so factors, what are factors? Factors are the categorical variables that we have in statistics. So that means that they are variables that have different values, but they are not continuous. So, like for example, if we have a result of a diagnosis and we have the possible results of that diagnosis or treatment is, like for example, say it's a cancer, it's not a cancer, or it's not valid, for example. So then we will have this variable, we have three possible values which are really specified, and then it will be a factor usually, etc. So we have to be careful with them because we will see that they have an internal format that R is working with, and they have an external one, which is what we are seeing ourselves. So one of the examples of a factor is letters. So R contains this kind of collection of letters that you can call it, when you say letters. Here we are taking from letter number 1 to letter number 5 with this command. So only take from letter number 1 to letter number 5, and you will see that the result is A, B, C, D, E. Okay, so now if I want to make a factor from that, I take this command. So I said x, I want that to be a factor. Let's do it in real time, and like this I will explain it to you. So x, I want to assign to x a factor, so I say factor. Okay, which factor, which value it has? I want it has, for example, this one, s. This factor, which values can it have? So this means the levels of it. So in the previous example we were saying that was cancer, not cancer, and not valid, for example, as a result. So now we know that are gonna be all the letters. So I say levels, which are the different unique values that this variable can take. Levels equal what? So letters, all the letters. Okay. So show me x. So if I do that, I will see the result is this one. The result here down, it's s. What the result is s, only s, which is the value of it, but it also says that the levels are all these ones. Okay, so these are the possible values I'm gonna have. So now I can also, let me erase that, I go here, I can also show the levels explicitly if I put this function here, levels of x, and I will see that all the levels of x are displayed here now. Then now let's do another new function, which is attributes of x. Attributes of x means which characteristics has this variable inside it. Okay, so attribute it has two: levels, which is this collection of letters, and the class, which is factor. Okay. Another useful one that we will use a lot is structure of x. So that's what does x contains in detail. So it says that it's a factor, and it has with 26 levels. So this is the structure of it. Okay, and it says also which is the level is number 19. So that's saying that from the 26 levels, the value of our variable is level number 19. Okay, so let's see if we see as an integer our variable x, which is the number is gonna be 19. So that means that inside R, x is number 19 because it's the 19th level. Okay, so to prove that to the internal coding, as we saw that I assigned this variable to the integer part of x. Okay, so in this case it's 19. But now I want to pass to the factor again. So now I only have this number, which is 19. But now I want to pass from 19 to the letter s. So how do I do that? So now I say y. Let's do it in real time. Y, we want it to be a factor. So we do that. Factor of what? Factor of this number. This number was 19. So if it's 19, I want that the levels are numbers also, because I want 19 to be the 19th one. So I go to 1, 2, how many letters there are. So I say length of letters. Length of letters. And then now the levels are the numbers, but I want them to be labeled as the letters. Sorry. So here I'm doing that. I'm saying it's a factor from a number. The levels are numbers that go from 1 to the length of letters, which is 26. So that could be, for example, here 26. This is gonna give me a list of numbers, a vector is called, from 1 to 26, but the labels are the letters, so it's like the character that they have is that. So let's apply that and see. So the result is the same, s with the same levels. Let's see if identical x and y, true. Okay, they are the same. Okay, so this is a very useful technique to pass from integers to pass to factor again, because we will see that sometimes it's much more quick to do operation over numbers than over factors, and it's specifically when the factors have a lot of levels. Like in our data, sometimes we have, like, say 4 million different women in Denmark, and then our variable of identity, for example, is gonna be one character string which has possible 4 million levels. So when we are using these kind of factors, it's sometimes it gets slow or it goes to memory and can make some problems in R. So it's very useful sometimes to pass from factor to integer and after to pass it again. If we know that x is a factor, so then we can do that to go back to the values if we have the numbers. So it's gonna be factor of the number, in this case 19. Levels are from 1 to the length of the levels of x, and the labels are gonna be the levels of x. So if we do that, we get the same result. But the good thing is that with this command we always can pass from one factor to numbers and after from numbers to factors. We will see that that can be very important afterwards. Now it's a little bit advanced, but I hope you don't get too confused with that. So same result. Now another thing important that we do with levels, with factors, is that we can change the levels, the order of the levels. So instead of saying the levels are A, B, C, D, I can say that the levels are B, E, D, A, C. And then I'm gonna change the internal values, because if the factor A had before the value number 1 because it was the first, now if I change the levels, the factor A internally is not gonna be number 1, it's gonna be number 4 or number 5. Okay, so let's do that. Factor A its levels, so levels of 5 different levels, but now I'm changing the levels, so I say levels, it's concatenating these values B, E, D, A, C, and now I want to x2 its factor of x, which is A, with the levels changed. So the result is gonna be the same thing, so A is the result, but the levels are B, E, D, A, C, and not A, B, C, D. So now if I want to see how is it internally coded, I will see that is number 4 instead of number 1, because now A is the 4th level. 1, 2, 3, 4. Okay? So now there is another kind of factor which are called ordered factors. That means that we can say which is greater than the other one because the values are ordered. Like for example, sometimes in screening or in diagnosis, we can put a diagnosis from the less harmful to the worst one. Okay, the more benign to the more deadly, you know? So then we can order these diagnoses and have to make some calculations over them. So here is how we code that. It's the same process of before, so factor of something, levels we defined, and we say that they are ordered. So if I do that, I see that here down I have the labels, and specifically it's saying to me that they are ordered. Okay. And then I can apply that, because for example if I define another one which is gonna be x3, a factor instead of factor of in this case A, it's factor of C, no, of D, for example. Okay, and so I say that, control enter, so to me it's D, and I say A is greater, no, sorry, x2 is greater than x3. That's a question, and it is true because A is greater in the levels than D. Okay, so this is a little bit more complicated. You see, we begin to see which is the basics, subtleties of R, but this factor element or class, it's very important, and you can perhaps kind of try to work with them a little bit, or see again this part and try to understand it, because it's gonna be very important. Anyway, we're gonna use it again and again, and after a few lessons you will understand much better how it works. Okay, so this is the end of the atomic classes in R. Bye.